Hi guys, we're back to continuation of this shell tutorial, and we'll be doing this task, which is the exercise super simple shell, which is the continuation. I think this should be day 3 part 3, right? So this one says using everything we've learned, right? Using everything we saw, write a first version of a super simple shell that can run command with their full part without any argument. So it's not going to have any argument. So we have to write a full shell program that will not have any argument. So when they list the content of this directory, you would see that we have the shell.c, we have the ppid executable file. Okay, so if you see, after they compiled the shell.c, they created a normal shell, they execute it, and then it brought in this prompt, and then with this prompt they did bin/ls, that's just the path name, and then it executed by listing the content, right? All these weights and everything, it listed it out, and then still brought them to another prompt, and then they input /ppid, which is this guy, to execute it, and then it print the parent id, right? And then we have this guy too. It brought out the prompt, they did it again, the parent id is still the same, as you know, and then they pressed Ctrl C, and then it exited from that program, and then brought them back to the starting point, the real shell. Okay, so this is what we'll be doing. So we'll be using basically what we've learned so far: our fork, our wait, our exec v, which other functions, name it, all those functions. We're going to combine them and we're going to use them to build this shell. So basically, let's get started. So the first thing I want to do is open my file, which will be shell.c, right? So I want to include the necessary header files. So we have the standard io.h. Sorry, I wasn't looking at my screen. Standard stdio.h. Okay, it looks small. Stdio. Okay, it looks correct anyway. So we include our standard library because we'll be allocating memory with malloc.h as well. And then we'll go to the next one. We we have so many system calls, so unistd.h, right? So the next one is we'll include system types.h, and also we'll include system weight, right? .h. Yes. Okay, so with this 5 I think we should be good. So I'm not documenting, so I'll have my main, so no arguments for now. You can just pass in void to it, so since a normal good practice. UID, and then let's come here. Sorry, let's go up. Good. So let's start little by little, and then we'll program it up. So the first thing I want to do is I want to print out to the screen, right? So let me just be doing it step by step. So any variable I'll need to declare, I'll come back up and declare it. So the first thing is we want this program to be able to print out this prompt to the user, right? So I will copy this prompt. So I can use printf, but because we are not using printf for this for our real project, so I want to familiarize ourselves with other stuff that we have to use. So we have to use write, right? Okay, so I wanted you to guess what we're going to use, but anyway, I said it first. So I'm going to be using the write function here. Okay, so write, and I would say you should just write to the standard output 1. What do you want to write? This. I'll paste it in the middle. I'll put some space. How many lines is it? 1 2 3 4 5 6 7 8 9. So I'll put 9 here. Okay, so if I compile this one and probably put a return value, a return of 0 here, okay, we're gonna have what's it called? If I say return 0, okay, and compile, normally this one will just print our output, right? Okay, so that is that. If I compile this and then it's gonna work, we're gonna get the prompt. But the thing is, the prompt will not keep repeating after inputting something. But first, after this prompt has been printed, we want to receive it, right? We want to receive it, and we'll use the getLine function to receive the prompt. So we'll say getLine function, and so you can also add an error message that if getLine return -1, it should print error. Okay, so getLine, and for getLine will collect 3 inputs, right? Getline will collect the buff size, and then we'll have our standard input, right? So we have the buff, right, we have the buff size, let's say size, and then we have our standard input, because normally it's accept files here, right? But for now we use our standard input, and then remember that it is the address that we are going to be passing. So use our ampersand and our ampersand, and the next thing is that we need to declare them here, the variables, right? So we'll say buff is a character pointer, right? Buff. Okay, and then if we want our getLine to allocate it memory for it itself, we'll set buff to null, right? And then the buff size, let me put it at the top. So that one is a size t, right? So our standard library would help us with that. So size t, so buff underscore size. So the buff size is what? The buff size is, we set it as 0. Okay, so with this, it's going to do the allocation for us. So far we've just printed this guy out and then collected it. Okay, so for us to though we still need to print it out, right? But for now we're not printing anything out yet. Okay, no, we are only printing this guy out and then collecting it, and then using whatever is being imputed, we are executing it, right? So for this guy to repeat itself, we'll put it in a while loop. Okay, so just say while loop, while, like this. So should I put yeah, okay, let's do it this way. So let me align it. Sorry, the tabs will not matter because I'm not betting this file. So anyway, so we have our while, so I'll just say while 1, which means while true. Okay, while 1, it means this is an infinite loop, this thing will continue till the end of eternity, right? So while 1, you should do this. So basically, if I should compile like this, gcc shell, the output should be, oh sorry, shell.c, the output should be shell. Okay, so if I run my shell now, we have our prompts. If I do this, okay, it just brought us back. So that guy received it and we didn't receive the prompts back. Let me see why what's happening. I wasn't expecting that though. Okay, let's go back to the shell. Probably we are not done. Shell.c while 1. Okay, so let's continue. So while 1 writes, so this guy will print out, this one will collect it and then return 0. Okay, I think it's because of this return. This return is not supposed to be here, that's why, because I was expecting it's not supposed to be here. So I'm so sorry about that. So it is return outside. Okay, so just try it again. Right, so let's do ls, for example. Can you see it's collect the input, brought it back, right? So we are getting there, right? So it's bringing it back like a normal shell would do. Okay, so I press Ctrl C, and then let's go back into our shell. Let's see. Okay, good. So we've set that, and that is done. So the next thing we'll do now is we are going to use string tokenization, right? So for now, let's say we'll say string tokenization, string token. So because of that, we're going to add the string function, right? So we'll say include the string.h header file. So string token. So whatever string token collects two parameters, right? Which is the content that is coming in, right? And then the content that is coming in, and also what's it called? What we want to the delimiter, right? Which is what we want to use to separate those. If there is probably we are separating with space. But remember that it says this guy says it will have no argument from the beginning, that has no argument, right? Without any arguments. So because of that, it means that we are just going to be passing one thing to it. Okay, so that's basically it. So for example, we'll say okay, we want to pass in our buff, which is the input that is coming in, right? And then our delimiter, we want to set it to be what? So our delimiter can accept more than one stuff. So we only want to separate if we have tab. If we have extra tab, it should probably it should set null to those points. And then if you have a new line, it should set null to those points, right? For our command to execute normally. Okay, so string token will return that part that we need, that first argument, right? So we'll say equals to, so you should return it and put it inside token. Okay, so we'll put it inside token, and then we'll declare token at the top. So token would be a character. It's gonna be a character pointer token. Okay, so we are returning it token. All right, so that being said, so we have that done, and then the next thing we're going to do now is so we will just set some other stuff. We'll say while token is not equal to null. Okay, so while that token while token is not equal to null, that is while we've not gotten to the end of this buff, right? That's what this guy says, right? We've not gotten to the end of this buff. Okay, so we want to continue doing this guy, right? So remember, for this guy, we want to continue separating it by tab and new line. Okay, so but before that, after this token has been gotten, we want to save that token inside a particular array, because our exec function works perfectly with array. So we are going to declare an array and say okay, an array, okay, an array, so array at index I, which is going to be 0. Okay, our array at index I is equal to the token first, and then we want to token is equal to string token, and then we'll have the same thing, buff comma new line t new line n. Okay, so what we are doing here is that after we've separated the first guy, so this place will not be buff. The new stuff says it should follow by, it should be null, right? Because it knows that the first one is buff, so it knows that we are still talking about buff. Okay, so this is what string tokenization does. So what we are doing here is that we are basically, so before, lest I forget, this I, let me just declare it at the top here. So we'll have our int I, and let us set it to 0. Okay, so and then this array, let us, so for array, we're going to make it a pointer of int, no, it's going to be a char double pointer array. Okay, and then we're going to allocate memory for array. So let us allocate our memory somewhere here. Okay, or yeah, let me allocate it here. So I will say array is equal to malloc size of char pointer times let's say 1024. Okay, so we are allocating space for array, right, to hold those tokens that will be separated by this string tokenization. So basically what we're doing here is that we've separated this, the first guy here will be held on this guy. So that first guy, we are giving it to array at index 0, and then down here we'll have our I++. Okay, so the next time it's going to be array at index 1, we are giving the next token, because this guy would have gotten the next token, we are giving it to this guy. We'll continue until it gets to the end of the string. Okay, so that's basically this part. Okay, so the next thing we are going to do now is we'll then create our processes. So we need our child process, because you know that our parents execute first, right? So we need our child process. We'll make our parents wait, make our child process execute that command before it returns. Okay, which might not even return, but anyway, so let's go. So what we'll do is we'll say let's see, but before that, the end of this array, at the end of this loop, needs to end with a null. So what we'll do is we'll say the array will then pass in null to it. By the time it comes out of this loop, it will have increased by 1, and then we'll pass in 1 to it at index I. Okay, so we'll pass in null to it. Okay, so that's that. Then we'll create our fork. We create our child, and then remember that fork will return some values. So let us call it the child PID, right? Process ID. Okay, so for that one, we'll do our PID underscore T to hold that, PID underscore T to hold our child underscore PID, right? So okay, good. So we'll then use the value that will be returned to child PLD to know which one is child, which one is parent. So that's what we're gonna do. So to do that, we'll say, let me put it here, if our okay, bracket child underscore PID is equal to 0. If it is equal to -1, you can add that together. If it is equal to -1, then you should print error. So if it is equal to 0 is what I'm concerned about, because that's what we want to use, the child process. So if it is equal to this, right, we'll have something here. Else, let's just finish the else. Else, it means this one is for the parents, right? So else, we can just say it should wait, right? And then we'll pass amper status. Okay, so we'll declare status at the top as well. We have one int here already, so let's just put status beside it. So let's say status, comma, yes. So this should work, and yes, we are done with that. Because we are passing one argument to else, we don't need to put in block there, right? So that's it. And then we are done with that. And don't forget, we are going to free that buff, right? We're going to free buff. We're going to free buff, and is it buff? Is it buff that we're going to free, or Harry? I can't remember. I think it's Harry, but anyway, we'll come back to that. So are we free? I think we're still inside the first loop, so we are supposed to free it outside here. So at the end it should free but let's wait. Okay, I think the one we allocated memory for is the one we are freeing, but we are supposed to free this guy too. So we'll free, I think array is what we allocated for, and then we'll free buff too. So we'll free buff, we'll free array, right? So we'll free both, and then that's that and that. So for the child process now, what are we going to do to child? That's where we are going to execute our program. So we'll be calling our exec function in this child process. So we'll say if, right? So we'll say if then we can call our exec function, right? Exec ve, and exec will collect 3 arguments, right? So in order not to confuse you, let me first remove this if statement, right? So we want to execute some commands, right? So we'll say this guy should execute, this one will be the first command, right? The command itself, which is array at index 0, right? And then this one will be the O command, which is the array itself, and then the last one will be a null. Okay, because this guy has to end with null, that's why we had to put null here as well, right? To end it with null. Okay, so and then that's done. And then so we'll say if, so this is just like defensive, right? So if this guy returns -1, so if this guy, right, is equal to -1, then it means an error occurred. So we can use error to print an error message. Okay, so we just say error with the exec, right? So an error with the exec. Okay, so print an error message, error with the exec, and then I think that is that. Okay, so what else? I don't know, do we have anything left over? So let us try it and see if it works. So if you have any message, we'll debug, and then though we are supposed to use the flag, let me still see if I have it on my clipboard. Okay, I don't have it. Alright, so let me get it here. Okay, so we have some stuff. Talking about tokens is not equal to null. Okay, what did you mean to dereference the pointer? Okay, so let us go back there. So vi shell dot c. So that while token is not equal to null, we can also replace it as while token, so it should work that way. Okay, so we'll say while token. So alright, so let us recompile. Okay, it worked. So we'll clear it and then let us run our shell. Alright, so it brings us to a prompt, and then let us enter that prompt, user bin/ls. So it listed our stuff. The one in this guy is user/ls, bin/ls. Is it bin/ls? Let me see. Yeah, bin/ls. But the thing is, on our own system it is user bin/ls. So I don't know. Error with the exec, bad address. Okay. The exec would not execute this guy because it's not part of this stuff, right? So let us see if we can run this ppid. Okay, so it means we actually have some issue to solve in our code. The first one won, but the second one is not running well. So let us see. So let us via our shell.c. If you look at it, we have our status, we have child, we have our token, we have int high, we have this one null, and then we have this one set to 0. Okay, so another thing I would do is my high, when I get here, I can say I equals to 0 just to reset our high as well. And let us try that. That might be the problem. So let us compile and run again. Shell. Right, so let us see bin ls, because this bin ls I think is supposed to work. Okay, bin ls work now. Look at just that simple thing. Okay, so let us see ppid. Okay, so ppid is the one not working now. So if I have user bin ls, user bin ls too is not working. It's just bin ls that is working now. Oh, bin ls is not working too. What's wrong? It's only the first command that is working. Okay, so everything is working. It's just that it's the first command that is working. So let us compile again. Let me just rerun it. So if I do /ppid, so it's going to do that, and then if I do that again, it's not working. So there's something with the function that we didn't do right. Okay, so vi into the shell.c while the second one is not working. Okay, so if you should print error. Okay, print error. Let's see. PID equals to 0, else weights and status I equals to 2. I'm coming. Let me remove this return 0 and see if it's gonna work. Okay, so let us compile. So let us have /ppid /ppid. So we still have our error. So we enter our shell.c again. So let's see where would the error be. We've written the first guy, get line. I feel it might be this tokenization part. While token array at index I equals to token equals to string token null tn, and then I plus plus I equals to null, child PID equals to 4, PID equals to 0, exec this and null. Yes, print error. So I don't know, print error. Definitely not this one. Else. we should wait for status. I'm sure it's not this, but let's just add it. So wait for status, and then okay, wait for status. Maybe our free should be up inside this guy. So let us see, free buff and array, free buff, and then free array. Okay, so let's try. I've removed my I equals to 0, remember. So let us recompile. Oh, sorry, it is buff, just normal buff. Let's just go to the so that run. So let us try. So we have a PPID, that will PPID. Okay, it worked, and then double free detected. Okay, so let us just free the one we allocated memory for and leave the one that shell is creating for us. So let us remove this guy. Okay, so let us clear our screen and let us recompile, and then let us see. Okay, / PPID, and then /PPID. Okay, and then /PPID. Okay, so it's working perfectly now. So let us see our code. Let's see user being ls. I think that should work. And also, what's this? Being ls. What about being ls? Okay, so it's not still working perfectly. So we still have some things to work out with this, because this one is just printing it in 3 different parts. So it's executing right, but it's not printing our command as we want it to list it out. So vi into the, okay, that might be the I that I moved. So let us see, vi into your shell.c, and then let us add our I. Okay, let us see again. So /PPID, and then /user being ls. Okay, /being ls. Okay, and then /PPID. Alright, good. So it's working perfectly now. So let us check the code and see what we've done so far. Alright, so basically, let me reduce the screen. Okay, good. So we added everything we need to add, and then we set our buff size to the 0 and this guy to null, right? So before I was trying to free this guy, but basically maybe because getline was the one handling it, so we don't need to free it. So the thing is, we have write, which will write to the output. We have getline, which will get the output, and we've set it. They are both pointers. This one is pointer, and then this one is a normal value, but we're passing the address for both. Okay, so we have the token, which will collect whatever this guy splits, and we just set it to tab and new line because we are not going to have argument to it, right? So token will be holding it, and then for that token that is going to be holding it, we declared a character token. As if you check the string token function, you have to just have a character token to hold it. Then we set an array to hold those tokens. right, to point to those tokens. So we allocated malloc for it, so it is a pointer to a pointer. That's why we are allocating a normal one pointer, okay, to it, right? So that I can point to those pointers, right? So, and then we have PID to hold the parent ID. Anyway, so we went through this one is in a while loop, everything, right? Because we want this guy to be printing back and forth through every command. So we then say that, okay, while we've gotten the first token, right, we want to um, get the remaining token. So to get the remaining token, you have to call this, put it in a loop, right? To get the remaining token, right? This one does not have many tokens, right? But we just have to do this, right? I think if we comment out this guy, it might still work because it's only one command that we are putting, so it might still work. So should we try it? I don't know. Let us try it, and if I try it, it means that my I has to be at index 1 here, because our null would have placed I to be 0. So you can try that on your own and see if it works for you, because I don't want to mess up with this code again. I've already spent enough time and I don't want to waste your time. Alright, so that's basically what this guy is doing. The array points to collect all these tokens, save it by increasing this one. I is 0, and then it increases, it collects it till it's done. So by the time it's done, the I still increased by 1, and then that last one we pass in null to it. Then we created our child parent process ID. So we want our child to execute this guy, right? So our child will enter this loop because the return type will be 0, and then it will enter this guy, right? So if it is -1, or this, we didn't set for -1, so we can still have some errors here. Okay, so it's going to be a good practice to just say if to first say if this guy returns -1, he should print a particular error or an exit, or and then this else if it is probably greater than 0. So you can ask else if it is greater than 0, you should wait. So this, because this guy will want to print first, okay, so we have to wait first, and then this status will make it get the status of the child if it is done, and then it will once it's done, before this guy wants to executes, right? And then that I'm setting it back to 0, because if I'm going back, it should start from 0. Okay, and then the array that I allocated, I freed it here. Okay, and then we close that while loop, and then we close our main program. Okay, so this exec collects 3 inputs, right? It collects the null, which is the this one is the environmental variable or something, and then this one is the command arguments, right? So the arguments are in arrays, right? Array is pointing to all the arguments, so we are passing array, and then this one is the first argument itself, which is array at index 0, and then if it returns -1, we have to print error. Okay, so I hope this expatiates a bit on it, so you can just try and read on it, and then you'd probably get it. Okay, so if you have any questions, let me know, and don't forget to hit the subscribe button, and thank you. That's all. Bye. See you in the next one.